At the very heart of modern physics, there's this grand contradiction, right? A place where our two best theories about how the universe works just completely break down. But what if that conflict isn't a bug? What if it's the feature? What if it's the very engine that drives everything? Okay, let's get into it.
Just asking this one question. It completely flips the script on a problem physicists have been wrestling with for 100 years. Instead of trying to fix the conflict, we're going to look at it from a totally different angle. We're going to ask if it might actually be the source of all the amazing complexity we see in our universe.
So first things first, let's really set the stage here. To get why this new idea is so wild, you've got to appreciate the sheer scale of the problem we're talking about. This isn't just some mystery, it's arguably the biggest unsolved puzzle in all of physics.
Okay, so on one hand, you've got quantum mechanics. It's the wild, wacky rulebook for the world of the super small. Particles, probabilities, all that weird stuff. And it's unbelievably successful. Then, on the other hand, you have general relativity. That's Einstein's masterpiece, right? It's this beautiful geometric picture of gravity that describes planets, stars, and galaxies. And it's also unbelievably successful. They're both giants of science.
But here's the thing. They do not play well together. When you get to the most extreme places in the universe, like the very heart of a black hole or the first instant of the Big Bang, you need both of them to work at the same time. And when you try that, the math just completely falls apart. It spits out nonsense, like infinities. It's because their basic ideas about how reality works are totally, fundamentally incompatible. So, how do you possibly bridge a gap that big? Well, the answer might come from a really unexpected place. We're going to shift gears from the cosmos to the study of poverty. It's a search for a law that might just govern everything. So you've got this researcher, Dr. Nimrod Israeli, and he's not even looking at black holes. He's trying to figure out a really human problem. Why do some communities thrive while others get stuck in poverty? And in doing that, he noticed a pattern, a deep pattern that seemed to be everywhere.
And what he came up with, he calls it the universal law of increasing complexity, or ULIC for short. The big idea here is pretty simple, but it's profound. New things, more complex and capable things, they don't just pop into existence. They emerge when three essential ingredients line up just right: a flow of energy, a stable structure to hold that energy, and a clear direction to guide it all.
Now here's where it gets really mind-bending. The claim he's making is huge. If this law is truly universal, it can't just explain how a village gets a new well. No, it has to explain the whole shebang. Particles, galaxies, the fundamental workings of the cosmos itself, which means it has to explain that great mystery in physics. So the million-dollar question is, does it hold up?
Okay, so if we're going to test this thing, we need to know what we're working with, right? Let's break down these three key forces of emergence: energy, structure, and direction.
Think of it like a recipe, a really fundamental one. First, you need energy. That's the fuel, the raw potential for anything to happen. Then you need structure, a container of sorts, to give that energy some form and keep it from just dissipating. And finally, you need direction, some kind of pressure or goal that points the energy toward a specific outcome.
So let's just look at these roles one more time. You've got the fuel, which keeps everything dynamic. You've got the container, which gives it coherence and stability. And you've got the guide, which orients the whole system toward the future. And according to this law, when you get these three things, the fuel, the container, and the guide, to line up just right, that's when the magic happens. That's when something totally new and way more complex can be born.
All right, framework in hand, let's go back to the scene of the crime, physics. This is where it gets really good, because that giant contradiction we started with, it stops looking like a problem and starts looking like a core piece of the cosmic engine.
So now, let's look at that big cosmic clash between our two greatest theories. But this time, we're going to look at it through the lens of this universal law of increasing complexity. And this is the light bulb moment. What if? What if quantum mechanics, with all its chaotic, probabilistic, buzzing fluctuations, what if that is the boundless energy of the universe? And what if general relativity, with its smooth, predictable, geometric fabric of spacetime, what if that is the cosmic structure that contains and organizes all that energy?
Okay, so that gives us energy and structure. But what about the third piece, the direction? Well, this is the coolest part. The law says the direction isn't some separate thing added on top. No, it emerges from the tension between the other two.
The very friction, the incompatibility between the quantum world and the cosmic structure, creates this constant pressure that pushes the universe forward, driving it to evolve and change.
So, if you have this cosmic engine running for billions of years, what do you get? Well, the law predicts you'd see a clear, directional arrow of increasing complexity over time. And when we look out at the history of the universe, that is exactly what we see.
And check this out, this process isn't just a random jumble of events. There's a clear path, a sequence you can trace. From the raw energy of subatomic particles, structure emerged to create atoms. Those atoms then linked up into complex molecules. Those molecules eventually gave rise to life. And after billions of years, life evolved consciousness. Each step is an emergent leap, creating something totally new.
And that's where you and I come in. This isn't just some abstract story about stars and particles. We are part of it. We are the direct result of this cosmic process. A universe that has become complex enough to look back and wonder about itself. To try and figure out the very laws that created it.
Okay, so this is a super cool theory about the cosmos, but so what? Why does any of this matter to us, here on Earth? Well, if this law really is universal, it's not just about physics, it's a blueprint for our own future.
Dr. Israeli has this quote that I think just nails it. For basically all of human history, flying was impossible. A myth, a dream. But once we figured out the laws, the principles of lift and thrust and drag, it became something we could engineer. It became a tool that absolutely transformed our world.
And that right there, that's the whole point. Once you understand the rules of the game, the laws of how complexity and capability actually emerge, you're not just a spectator anymore. You can move from just hoping for a better world to actually designing it. This could be a practical guide for building better organizations, stronger economies, and more resilient societies.
Which all leads to one final huge question. If these same fundamental principles, this dance between energy, structure, and direction, can build everything from a single atom to an entire galaxy, could we consciously use those same laws to solve our biggest, most stubborn problems, like poverty? The theory suggests, yeah, maybe we can. And if that's true, well, that changes everything.